Oil contamination in the intake manifold is one of the most common issues in modern engines. Understanding how this happens is crucial for proper diagnosis and prevention. The intake manifold is a critical component that distributes the air-fuel mixture to each cylinder. It sits on top of the engine and connects directly to the combustion chambers through intake valves. The primary cause of oil in the intake manifold is the positive crankcase ventilation system, or PCV system. This system is designed to remove harmful gases from the engine crankcase and recirculate them through the intake. When the PCV system works properly, it creates a controlled vacuum that draws crankcase vapors into the intake manifold where they are burned in the combustion process. However, when the PCV valve fails, excessive oil vapor enters the intake system. Here we can see what oil contamination actually looks like inside an intake manifold. The black, oily residue coating the internal surfaces is a clear sign of PCV system problems or other mechanical issues. Gasoline direct injection engines are particularly susceptible to this problem. Unlike traditional port injection engines, GDI engines inject fuel directly into the combustion chamber, bypassing the intake valves entirely. Another major cause of oil contamination comes from worn engine components. Worn piston rings create excessive blow-by gases that overwhelm the PCV system's ability to handle oil vapors. In turbocharged engines, turbocharger seal failures can directly introduce oil into the intake system. The high-pressure oil used to lubricate the turbocharger can leak past worn seals and contaminate the intake manifold. The type of oil contamination tells us about the severity of the problem. A thin oil film usually indicates normal vapor condensation, while thick oil accumulation suggests serious mechanical failure requiring immediate attention. Understanding these causes helps mechanics and car owners identify the root problem. Whether it's a simple PCV valve replacement or more serious engine wear, proper diagnosis starts with recognizing how oil enters the intake system. Proper diagnosis of oil in the intake manifold requires a systematic approach using visual inspection and precise testing methods. This process helps identify the root cause and determine the most effective solution. Visual inspection is the first diagnostic step. Load the engine diagram to examine oil distribution patterns in the intake system. Look for specific oil patterns in the intake manifold. A thin oil film indicates vapor condensation from the PCV system, while thick accumulation suggests mechanical component failure. Pressure testing measures crankcase pressure to evaluate PCV system performance. Normal crankcase pressure should read between 1 to 3 inches of water column at idle. High crankcase pressure indicates excessive blow-by from worn piston rings or cylinders. Low or negative pressure suggests PCV valve failure or vacuum leaks in the system. PCV flow rate testing measures the volume of air flowing through the system. Proper flow rates typically range from 3 to 5 cubic feet per minute, depending on engine displacement. The graph shows how PCV valve flow characteristics must match blow-by gas production across different engine operating conditions. Proper balance prevents oil contamination while maintaining adequate crankcase ventilation. Once diagnosed, several solutions address oil contamination. The most common fix is PCV valve replacement, which resolves about 60 to 70% of cases. For severe cases involving worn piston rings or valve seals, engine rebuild or component replacement may be necessary. Intake manifold gasket failure requires gasket replacement and surface inspection. Regular PCV system maintenance can reduce oil contamination by up to 80%. This includes replacing PCV valves every 60,000 miles and using quality engine oil. Aftermarket oil catch cans provide additional protection by intercepting oil vapors before they reach the intake manifold. These systems are particularly beneficial for high-performance and turbocharged engines. Success rates for different diagnostic methods vary significantly. Visual inspection achieves 85% accuracy for identifying oil presence, while pressure testing reaches 95% accuracy for determining PCV system functionality. A systematic diagnostic approach combining visual inspection, pressure testing, and flow measurement provides the most accurate diagnosis. This methodology ensures proper identification of the root cause and selection of the most effective repair solution.